Machine shop tucked our block into this nice little blanket. The surface finish of this block is looking awesome. They did a great job. Probably overcharged me a little bit, but that's all right. Most people don't want to deal with a diesel block. The block was hot tanked, but that doesn't mean we can't double check that it's clean. Still a lot of crud. Yeah. Then just gonna spray them down with some WD-40. All clean. Even though this block's been hot tanked, there's still a ton of crud in these water jackets that we have to get out before we assemble it. Also, while we're in here, there's a bunch of casting defects that whenever I take apart a motor, I like to clean up just a little bit with a Dremel, get it out. I mean, look at that one right there. It sticks out 1/8, quarter of an inch. We're gonna clean all these up. We're changing the harmonics of the motor, running higher RPMs, more power. There's gonna be more vibrations. And, well, I just don't want anything to break loose. You already got the motor open. You might as well take care of it. Now it's all cleaned up, nice and flat. Just gonna go around and do that for all these rough spots. I don't want to wash out this block twice, so before we wash out the water jackets of all that crud, I'm going to go ahead and prep the block for paint a little bit. What I'm doing is completely unnecessary, but it ends up with a nicer finish on the paint job. We're going to be grinding the block casting down just a little bit to smooth it out. There's a lot of imperfections in the casting of a block, and if you sand it out, your paint job will come out a lot better. Even though this thing's been hot tanked, you really want to give it a good bath before you assemble it and paint it. So that's what we're going to do right now. Just a lot of Dawn and some heavy duty degreaser. It'll take care of business. Spray them with a ton of WD-40. WD and WD-40 stands for water displacement. It's really good at displacing water. So hopefully these old girls won't rust. Need to hit inside of here where our tappets go. Those are bare metal, they're gonna get rusty fast. Like before, gonna wipe these out, hit them with some more WD-40 and then some ATF. That heavier oil will hopefully stick in here, that way they don't rust. The next step before we can mask it off and paint it is heating this block up. These blocks are cast iron. Cast iron can hold a lot of moisture in it, so normally you'll heat it up before you paint it. Hopefully that'll get all the moisture out and it'll make your paint job last a lot longer. I'm gonna light it way over here so we don't get any of this soot on our block. Move it over once we get a neutral flame. We got a neutral flame now. I don't have a heating tip, I only have a cutting tip. That's all right, we're just gonna be careful. Yeah, you basically run over the whole block. You'll see the metal changing color as the moisture gets out of it. You can kind of see a line where it's starting to come out as we're going. Just go over the same area one more time. Make sure it's all out. See, you can see that line of moisture going down further and further as we're heating her up. So when you're painting an engine block, you don't want to paint any mating surfaces, so you end up putting a lot of the parts back on. This is our rear cover that holds the rear main seal, and before we put it on, now it's kind of overkill to do that with this rear cover because it's not even going to be seen, but it's going to bother me if I don't. Just like with the rear main seal cover, I taped the back, so hopefully I don't get any paint on this thing. This piece is actually aluminum, and we're going to try to polish it here shortly. So on top of masking off surfaces, you really want to protect your threads. So if you have the bolts, put the bolts back in. You can throw tape in it. Some guys will use foam earplugs. Just roll them up and stick them in there. Another thing to think about, down here on the oil pan, these bolts, their threads are exposed from the top. So if you start painting this block, paint drips down in there. Even though you covered the bottom with tape, still ruined your threads. What I like to do, just take a pick, stick it in there, roll it out a little bit, stick your bolt right back in there. Got all the oil pan bolts in. This whole thing is masked off, and now ready to wipe her down one more time and give her a paint job. Cleaning projects like this right before we paint, I normally use acetone. I'm not sure what's the best thing to use. I can just tell you what I use. Probably gonna end up having to wipe this block 2 or 3 times before she's good enough. This is the paint we went with. Matte black. We're going with matte black, gloss black, and then we're doing chrome as well. Well, not chrome, but polished aluminum. Engine should come out looking pretty good. Just gonna put it on with a foam brush. We got our first coat of paint on this block. We gotta wait 20 minutes for the next one. Over here it already started to dry a little bit. You guys can see up here I also laid it on a little bit lighter. Starting to see that I didn't like it as it was finishing, and the rest of it I started laying it on a lot heavier. It's been 20 minutes. She's still a little damp on this side, but this other side's pretty dry. We're gonna go ahead and put on that second coat. Oh, she's looking good. Well, we got our second coat on. I think that's where we're gonna stop. 2 coats, that's what they recommend. That's what's looking really good for us right now. Got plenty of work to do. I gotta take all these bolts out before this fully cures, and I'm gonna get all this paint off. Bigger bolts and a thing of thinner. Give it a second, everything comes off. See, we still got some on the head right there. You can just rub it with your finger and it'll come off. Gonna do the same thing with our oil pan bolts. Some of them got a decent amount of paint on the tip of them. So you guys can see we made kind of a mess. That's all right. Let me peel the tape off and show you guys how to fix it. Same thing. Just wet your rag with some of it. Scrub just a little bit. It'll come right off. We're polishing this, so it's not a huge deal. I can always sand it off later, but doing it this way is gonna save me a little bit of frustration later on. The reasoning for taking the tape off before everything's cured, if you try to take it off when it's cured, it's gonna be like concrete. You're never gonna get it off. It's gonna be stuck under the paint. And well, you just save yourself a lot of time if you peel it off when it's still just, a little damp. With the engine block being painted, it's time to get all of our small parts ready to go. This is kind of my setup that I use. It's a grate off like a semi truck or a trailer that my old man got it propped up off the ground. Pressure wash it. You guys know if you pressure wash stuff on the ground, you get dirt everywhere. So this is kind of my mitigation tactic. With all of our small parts being pressure washed, we got to get all this rust off of them, get them painted so we can throw them back on the motor. So let's sandblast them. Just like with the engine block, anytime before you paint, you gotta wipe it down. You gotta prep the surface. I already blew these off with some air. With that blasting media that I'm using, the aluminum oxide, you can actually see it in it. It's like sparkly. You wanna try to get all of that out. It's gonna give the paint better adhesion, but also as these materials heat and cool over thousands of miles, that sand isn't heating and cooling and expanding and contracting at the same rate as the metal, and that's going to cause the paint to crack, start peeling, ain't gonna be good. I sandblast all the external parts just because it's fast, but you want to try not to sandblast your engine before you give it a paint job. Reasoning is, it's a lot harder to get sand out of the engine. These are the pistons that came out of it. You guys can see I got it cleaned up. It's looking a lot better. They originally started out looking a little worse than this one. This one was soaked in some brake clean, and that's why it's looking a little bit cleaner. There's still some gnarly carbon buildup on them. Kind of hard to see on the camera, but some of it will not come off no matter how much you soak it. This is what our pistons have been soaking in for the last, probably 4 days. Before that, they were soaking in carb cleaner for about 2 days, and I didn't notice a difference, so I swapped them over to this stuff. Here's that carbon buildup I was talking about. 200,000 miles showing on these pistons. Now, whenever you're wire wheeling something like this, or really anything, wire wheels can take off a ton of material, especially if you start nicking corners. That's why for most of it, I'm going along with it. So hopefully we're not taking off that corner up there. I've tried scraping it off with a plastic scraper and other methods. Nothing wants to get this carbon buildup off. It's pretty gnarly stuff. Normally soaking the pistons in some carb cleaner will normally get almost everything off. If you guys have anything better to use besides brake cleaner or carb cleaner to get all this stuff off, please tell me. It'll save me a lot of time. But you got to clean up where the rings go in too. Most guys recommend taking your old ring and kind of just rubbing it through there, knocking out all the big deposits. That definitely works. It's slow. Another way, once again, wire wheel on a Dremel, just run at a really low speed, stick it in there, just real light, and it'll take 3/4 of it out in just one pass. Just to give you a little side by side, lots of carbon buildup on the top. These were even worse before I soaked them. And then lots right here on the side of the piston. Ideally, the best thing to do is always to soak it when you're wire wheeling. Once again, you're taking off material. It's not the best practice, but I could not get that carbon off of these pistons. It was stuck. We got all the pistons cleaned up, and while cleaning them up, I found something a little peculiar. It doesn't look like casting marks. It looks like something rolled around in that cylinder and whacked the top of that piston a couple times. I like wiping down the top of the cylinder with some engine oil, just so I don't scratch anything when I'm putting the in and out. Then take your ring, jam her in there. Use your piston to get her flush. You want to make sure you don't have the ring in there cattywampus. So you look at one of the rings. So you can see I lined up the block with the slot for the intermediate ring. So this thing's going to be perfectly level in there. And now we measure the piston end gap. Minimum's 0.4 millimeters. So you try to get that in there. Doesn't look like our minimum's going to fit, so we're going to have to file this ring. Take it out. So this is a cheap ring filer, and just set it in here. Use this little notch to hold it in place. Hold it up against the grinding disc, and then you go to town. When you grind, you want to make sure that you always do it from the same side of the ring. And when you're done, make sure you clean up the edges of any burrs. It takes a decent amount of time to take some off. but you want to keep checking it to make sure you don't take too much off. Our minimum is 0.4 millimeters, and it fits. But our max is 0.7. That's a pretty wide range, but that's not even close. I want to put us kind of in the middle of that range, so we're going to keep filing this thing. I got every single one of those top rings in. I wanted the gap to be about 0.6 millimeters. This is 0.58 on this feeler gauge. 5/8, 5/8. Just barely catching the... Yep. So I'm gonna take all these rings out, set them on the table, keep them organized in order, 1 through 6. You line it up with the solid part of the spring. Make sure that that thing gets seated in there all the way around. This one, I'll normally start the back side first. Get it in the top groove. And then bring the other side down to the next groove. Then just use a pick, push it down. There we go. Second ring's installed. Same thing. I normally start with the back on the top 2 rings. This project's been pretty delayed due to part shipping, and in the meantime I'm kind of getting bored and I'm doing other stuff. These are our freeze plugs. They're in kind of different stages here so you guys can see. This is how they came. These are freshly milled, not perfectly flat. This one is sanded down to 1500, ready to be polished. And this one is polished. She's not perfect, but I don't normally sand aluminum. Pretty shiny as it comes, but you know, why don't we make it a little bit better? Kind of like a dull shine. The factory manual recommends a 15 to 25 degree crosshatch. Normally, as long as you don't go over 45, you're normally pretty good. Deglazing the block's gonna help our piston ring seat. And if you go over a 45 degree, sometimes it'll cause the oil to slide down the cylinder walls faster than it should and not retain it. So then you have some wear issues there. All the way in the bottom there, right at the tip of my finger, is a piston cooling nozzle. The stock ones are plastic, so we're going to be replacing them with a billet aluminum one, and we got to punch those out. This is the punch I set up for it. Shouldn't take much force to take them out. Yep. These are the stock piston cooling nozzles. They're plastic, so a lot of guys will replace it with aluminum ones. There's a lot of guys who say, what in the world was Dodge thinking, putting a piece of plastic in an engine like that? Well, it survived 30 years. This is a stock engine. They were all still working good. I don't know if that's survivorship bias, but these were cheap enough, so I figured I'd just upgrade them. Same exact design, just aluminum, and they have a little knurling on there to hold them in place. These are your oil galley plugs. A lot of people forget to take them out, clean the oil galleys. As you can see, ours are definitely not perfect. Relatively clean, a little rusty. That material right there is the sealant around the galley plug. We're gonna have to dig that out. If you're rebuilding an engine, you should really know how the oil travels through the engine. That way you can clean it. If you guys are curious on this 12 valve, it comes from the pickup tube in the oil pan, through the pump, up through this hole, which leads out right there. And then it flows through the oil cooler and the filter to this one, all the way on this side of the block. You guys can see the light. And that fills up this tube. Each of these holes get oil from that tube right up here. So this one delivers the oil in to that bearing. And then this one, if you're wondering how your camshaft, just like that. Our front cam bearing's pretty good. This is only a cam bearing that you can replace. It's super cheap, so I went ahead and bought another one. We're just gonna go ahead and drive this one out, get the new one in. loosey on that. Oh, sorry, Henny. I got it. This is my torque wrench, and we're going to double check it before I do all these main caps. I do not want to be torquing everything to the wrong spec. Just going to hang a 20-pound weight from it. I set it at 20 pounds. Just see if it clicks. Woohoo. This torque wrench is way off. Right now, this is a 20-pound weight hanging from the handle. It should be clicking barely at 20 pounds, but it goes all the way, it clicks all the way at 32, just barely when you take the weight off. This is a 3/8 drive torque wrench that we have, and 20 pounds. When I take the weight off, it just barely clicks. I got a different style torque wrench here. You guys can see almost directly on the 20. When you're testing these, it does matter where you put this on the handle. Most of the times you'll put it in the middle, but here, let me show you guys. Move it just a little bit. And it went from 20 to about 25. So it does matter where you put it. And also, you really don't want to test a torque wrench at the bottom of its range, which I was doing with this one. But it being 12 off, I really don't know if I want to trust it. Now, with that other torque wrench, you could calculate how far it's off, and then you could do the math on what torque you're supposed to set it at to get the torque you want. I don't want to do all that. These old school ones work fine. The reason that the other ones fail is because there's actually a spring inside of them, and if you leave them turned up, it'll actually mess up the spring and it'll keep it compressed. It'll lose some of its energy. For the final torque, doing these 90 degrees. This is stressful. Oh, wow. Oh. And I'm going to take this right back out. It's my first time really using the micrometers and the dial bore gauges, so I just want to double check my work, and I have plastic gauge on every single one of those main caps just to double check the clearance. Plastic gauge really isn't super reliable. Fits in the 3,000ths. Some points it's a little bit, yeah, it fits in the 3,000ths just about perfect. Anything that touches metal you want to lube up. Some assembly lube. This stuff is super sticky. Get some on the top. Stick her all the way down in there. There we go. This oil pan has an unreal amount of bolts. I've already installed about 8 of them. That's how many more I have to go. This is our oil pump. You do have to prime it. So just fill her full of oil. Got a pretty cool sticker that I designed for the channel and the build. If you guys are interested in it, let me know in the comments or send me an email and let me know, because I can send some of these out to you guys, or if there's enough interest, I may even open a shop and start selling some stickers for you guys. Overall, I'm super happy with how this thing's coming out. The matte black on polished aluminum is looking really good. There's gonna be some gloss black accents in there, and I think she's gonna look really good. I gotta let you guys go though, because I gotta head to port and polish, injectors to install, and valves to lap.